Welcome back, Algebra 3, Advanced Mathematics. We're in Lesson 34, and we're going to do something a little bit different with some of these lessons, and I'm going to start with this one and see, how it applies as we go through the future, or future lessons. I'm going to do these by the subsections of each lesson, so like 34A, 34B, 34C, and I'm just going to make these a little bit shorter videos so that you can digest each concept independent of the others. So you don't have to watch the whole video and then forget what you learned in the first section. So we're going to try that to see how that works for class. So let's start with 34A. We're going to talk about summation notation. Summation notation uses the Greek letter sigma to tell us that we want to add a series of patterned values together. And the sigma notation calls that a typical element. So the number on top is going to be your greatest value. And the number on the side, or the pattern, I should say, on the side, whatever that formula, expression, whatever that is going to be your element. And they call it the typical element. You could also refer to that in your thoughts as the pattern that we're adding. The pattern that is added. And then at the bottom, if this is the greatest, then this is the least. And it's going to tell us what the least value for that variable is. So this is the variable, and this is going to be the least value of that variable. So quite technically, you could also do this. It'd be the same thing, right? This is just giving you, it's almost like it's saying y is equal to 1 through 4. So y is equal to 1 through 4. If it takes that to help you remember, then use it that way. Right? So what we're going to do, I'm going to show you how you put all this together. This is your pattern or your element that is being added. In all your formulas that you're going to see in the future as you go through mathematics, sigma represents addition. That's the only thing we ever do with this, is addition. We don't do any subtraction. It's just addition. Now, sometimes you might have a negative number, and that might apply to turn it into subtraction, but independently, everything is being added or combined. We know how that works in mathematics. So let's start with the first element. You're just going to start with whatever this pattern is and the lowest value. So this is going to be 1 squared because we're subbing in the y for the 1 value. And we're going to add that to the next pattern. And the next one is 2 because 2 comes after 1, and it's going to be squared. Plus 3 squared plus 4 squared. And 4 is as high as we want to go. So that's where we stop. That's all we're doing. So 1 squared is 1. 2 squared is 4. 3 squared is 9. And 4 squared is 16. And when we add all of those together, we get 30. That's all you're doing. Whatever this pattern is, we're going to sub in this number starting at the lowest value into the variable that it includes. That's all it is. Pretty straightforward and easy. The main thing is to remember what these parts mean. So let's jump right into an example problem. So in 34.1, we have this summation problem. And I'm going to try to draw it a little bit better. This is kind of more of what it's supposed to look like with the little kickers here on the ends. So we have a 5 here, a 3 here, and we have an I here, and I is equal to 1. Okay, so Miss Tracy, there is no variable here. Well, remember when we would say you've got to put the terms in descending order of the variable, and we would have 3x squared plus 3x plus 3. Well, this was x to the 1, and this is actually x to the 0, because x to the 0 is 1, so you're literally saying 3 times 1. So it's there, it's just invisible. And that's what you have when you see a problem like this. It's just that it is to the 0 power. You could put your variable there to the 0 power, and it's always going to represent 1, 3 times 1. All right, so that's what you're seeing without seeing it. We start at 1, we go to 5. So that means what this is actually asking us to do is say 3, we're going to substitute in the I to the 0 here. So I will be 1, so it'll be 1 to the 0 plus 3. Our next number is 2 to the 0 plus the next number is 3 to the 0 plus 3 times 4 to the 0 plus 3 times 5 to the 0. 5 is our greatest value, so we stop there. 3 times 1 is 3 plus 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 3 times 1 is 3. And we have 5 3's. 3 times 5 is 15. That's it. That is all that is. Let's do another one. Let's get some more practice in so we can see what we're doing. 34.2. Here is our cute little sigma sign here. And we have a 4, and we have 2x, and x is equal to, the lowest value is 1. So now we just start like this. We say 2 times 1 plus 2 times 2 plus 2 times 3 plus 2 times 4. Because 4 is our greatest value. 2 times 1 is 2 plus 2 times 2 is 4 plus 2 times 3 is 6 plus 2 times 4 is 8. 2, 4, 6, 8. We add those together, and that's going to be 20. Easy peasy. These are super, super easy. They're kind of actually fun because it's just a pattern. I love patterns. That's one of the reasons why I do like math, is the pattern and the orderliness that comes with it. 34.3. And that one is a little bit more complicated. I like it when they get a little complicated because then it's a challenge and you want to see if you can do it, right? So 3 is our greatest value. 2 to the j over j, j plus 1. And j is our variable, and the lowest value of j is 0. So all we're going to do is take this pattern and put it over here. So 2 to the 0, because that's our j, over 0 plus 1, plus 2 to the 1 over 1 plus 1, plus 2 squared over 2 plus 1, plus 2 cubed over 3 plus 1. So now let's do the mathematics. So this is going to be 1 over 1, which we know is 1, plus 2 over 2, which we know is still 1, plus 4 over 3, which for now we're going to leave as 4 over 3, plus 2 times 2 times 2 is 8 over 4, which we know is 2. So now we can address everything by making it have a common denominator of 3. So this is going to be 3 over 3 plus 3 over 3 plus 4 over 3 plus 6 over 3. We add all of that together and we get 16 over 3, and that would be our answer. So it's not so hard. It's really not. It's very, very easy. You just have to understand what all of this means and how to put it together. We've got one more, just so we know how to solve all the different types that we're going to see. 34.4. And this summation, here's our sigma, and it is 6. 1 over y is our typical element, and y is equal to 4. So it just goes from 4 to 6. So that means 1 over 4 plus 1 over 5 plus 1 over 6. Okay, so it's a little bit more difficult because we have to get a common denominator. But we can do this. All right, so first I'm going to look at the 4 and the 6 because I know that their common denominator is 12 with that. So 3 times this, so it's going to be 3 over 12 plus 1 over 5 plus, and then 2 over 12. All right, now looking at the 5 and the 12, 60 is going to be my common denominator. So 5 times this is 15 over 60, plus 12 times this is 12 over 60, plus 5 is times that's going to be 10 over 60. Now I add all that together, and that's 2737 over 60. And this is a prime number, so I can't reduce it. So that's my answer. Not so hard. Easy peasy. And that's all I have for this part of this lesson. I'm going to do some practice problems after this that are these types of problems, and then we'll move on to 34.B.